There's another factor that could determine what kind of reusable rocket may become the popular model: the rocket fuel. Blue Origin uses a combination of liquid hydrogen and liquid oxygen, while CaspACE is planning on using kerosene and liquid oxygen. And both choices have environmental and financial pros and cons.
Kerosene mixed with liquid oxygen is dirtier than what Blue Origin does, but it's actually much, much cheaper.
Blue Origin founder Jeff Bezos has said working with liquid hydrogen is challenging, but that this fuel component would be important for the company's future projects. CaspACE said the design of its engine is meant to keep costs low.
So it's actually, if you're going commercial, you need to see what is the best option, and it becomes a more viable commercial proposition. You can make a profit.
And to make these plans commercially viable, Blue Origin's rocket and the one planned by CaspACE would use different landing systems. The Chinese company is designing a tower that will catch the rocket, whereas Blue Origin uses fins, drag brakes, and landing legs to help it touch down softly. Space companies are still weighing how much to invest and determining the demand for these types of trips, since reserving a seat is expensive. But mastering the reusable technology ultimately isn't only about tourism.
Space tourism is a very small part of the overall space economy right now. But in terms of the technology side of things, reusable rockets are definitely a really big enabler of a lot of other things.
The race for a better rocket includes launching satellites and sending crew and cargo to space stations, even one day facilitating deep space exploration to the moon or Mars. But industry experts say there's currently a launch bottleneck for some of these missions because there aren't enough rockets, and building one can take months, if not years, and cost millions or even billions of dollars. So the company that could perfect the reusable technology would not just help relieve that bottleneck, but also grab a larger slice of the growing industry. Blue Origin and CaspACE didn't respond to our request for comment. For China, these commercial possibilities could help further open up its space program, which has been strictly controlled by the government.
They want commercial companies to play a bigger role in innovation. So I think that's going to be increasingly important, even for the things like, the high-level civil Chinese space program.
And for US companies, these commercial possibilities may mean a closer relationship with NASA, which has already partnered with Blue Origin for its launch services. For now, the space race for tourists is just the first step.
We're still waiting for the game changer in terms of propulsion technology, but reusable rockets and reusable tech are making big strides around the world and getting more efficient and more reliable and more safe.
And if this game changer arrives, it'll open up the potential of a much larger future in space for both the US and China. This is the Nancy Grace Roman Survey Telescope, or Roman for short. NASA is set to launch it into space in 2027. And this is China's survey telescope Tian, that's set to launch a few years earlier than Roman. These two telescopes are racing to map the universe in more detail than ever before, in the hopes of solving some of science's greatest mysteries, like how a little understood force known as dark energy helped shape our universe.
Potentially there's even a Nobel Prize there, right, if you figure out what dark energy is.
So we unpack the technology and design behind these telescopes, because a country that can capture the best images may lead the future of astrophysics research.
Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
Space telescopes are crucial tools for avoiding the light pollution and distortion that limits ground-based telescopes when they look out at space from inside the Earth's atmosphere. An American physicist first proposed space-based observatories in 1946. And then about 2 decades later, the US sent up the first operational space telescope. The Soviet Union was close behind, sending up its own first space telescopes only a few years later. Since 1990, the field has been dominated by NASA's Hubble, until the recent launch of the James Webb Space Telescope, or JWST for short.
Both Hubble and JWST are telescopes that look at a very small part of the sky in a lot of detail.
Jonathan McDowell is an astrophysicist at the Harvard-Smithsonian Center for Astrophysics. He's worked with NASA and has been monitoring space activities and satellites for 3 decades.
They aren't used to kind of look around and go, oh, I wonder if we'll see something here. You look at something you already know is there, and you stare at it in detail.
This is where the race to build the next generation of telescopes comes in, with survey telescopes that can map out large areas of the sky. NASA's Nancy Grace Roman is named after the agency's first chief astronomer. Tian is China's first ever space telescope and translates to Survey of the Heavens in Chinese.
Let's make no bones about it. They're both fantastic and amazing facilities.
Quentin Parker is an astrophysicist and the director of the Laboratory for Space Research at the University of Hong Kong. He's been observing the rapid acceleration of China's space program for over the past decade.
You know, surveys, by their nature, throw up incredible things. You don't know what they're going to find.
Both telescopes are designed to learn more about dark energy, a mysterious pressure that scientists believe is responsible for the accelerating expansion of the universe and the galaxies inside it.
That will let us understand how our galaxy evolved, how the chemical elements in our galaxy evolved, how we got here.
But there are currently no telescopes that can detect dark energy, even though scientists say it makes up around 70% of the total energy of the universe. So the goal is for scientists to use Tian and Roman to uncover dark energy's secrets.
We're not collecting signatures from dark energy directly. We're looking at the way that its interaction with things that we can measure.
So US and Chinese researchers are racing to build telescopes that can answer the same question, but each with a different design. One difference is in the telescope's mirrors.
So if you throw a certain amount of light at the telescope, right, some fraction of it is reflected by the mirror, and some fraction of that is captured by the camera.
Roman's mirror is larger than Tian's, which means it will be able to capture more light, giving the final image more detail. But even though Tian's mirror is smaller in diameter, it has a field of view that's more than 3 times wider. This means it'll be able to image more of the sky over the course of its mission than Roman. While Tian may have an edge on image size, the quality depends on another important part of the telescope, the sensor module. The sensor reads and processes the light captured by the mirror and sends back information to Earth for scientists to turn into amazing images, like these ones from the James Webb Telescope. So having a less powerful sensor can create problems for the images that are produced.
You're likely to get images with more artifacts in them, with more noise, with less sensitivity. It can't see quite as faint stars, things like that.
McDowell says NASA's 6 decades of experience creating sensors that work under the extreme conditions of space give it an advantage over China's younger space agency.
The challenge for China is, can they match the sort of semiconductor technology aspects of NASA's cameras?
By having more experience with telescopes, NASA can also be more ambitious about how far it sends Roman. The telescope will orbit the Sun from a distance of about 1 million miles from Earth. That means Roman will be able to operate without constant changes in light and temperature, and NASA says that allows the telescope to collect data constantly. Tian, on the other hand, will stay close to the Earth and therefore be regularly blocked as it orbits, limiting the amount of time it can spend collecting data. But being that far away also means Roman can't be repaired if anything goes wrong. Tian will be near the Chinese space station, giving scientists on board access to the telescope if needed.
You can actually, not only can you repair it if it gets damaged or if the solar panels gets damaged or if something goes wrong, you can upgrade it. You can replace the camera, you can put on new filters, new instrumentation, give it a new lease of life, keep it going for longer.
However, what could be the most important advantage is Tian's launch date. China's space agency says it's going up in 2023, giving it about a 4-year head start on Roman.
They may steal some of the thunder from what the Roman telescope would have done.
NASA said in a statement that Tian's observations will complement its mission, and Roman has unique capabilities for the study of dark energy. China's Space Administration didn't respond to a request for comment on Tian's launch schedule and design. Scientists say both telescopes will play a significant role in learning more about the origins of the universe.
There's a lot of international recognition if you start to elucidate what's going on in the early universe.
But only one country can lay claim to being the first to make the biggest discoveries in astrophysics.